Hello, everybody. Thank you for joining us for today's webinar. Today, we're going to be talking about best practices that can help you build enterprise-grade APIs with Amazon API Gateway. My name is George Mao, and I'm a specialist solutions architect at AWS. So I'm responsible for helping our customers design and operate serverless solutions on the AWS platform. In my past life, I was a software engineer, and I'm also a Virginia Tech Hokie. So let's take a review at what it means to build on the serverless platform. When you build on the serverless platform, you're allowing your developers to focus on the application logic and writing the code that matters to your business. So instead of worrying about the hard details of infrastructure and the networking environment and the hardware infrastructure, you get to let your developers build the things that are unique to your business and let AWS handle all the hard details. So second, scaling becomes super simple. Servers, you get to scale by invoking APIs or applications in response to events. And AWS handles all the scaling for you on your behalf. So what that means is instead of scaling by adding more servers, AWS will scale on your behalf, and that means you have no idle capacity. Instead of having idle servers that are constantly waiting and listening for events to happen, AWS responds and scales your environment for you. Your environment is automatically ready to handle and scale. At 10 users, you can scale to 1,000 users or 1,000,000 users without you doing anything on your behalf. So perhaps the best of all, the fourth thing that you get from building on the serverless platform is you can automatically inherit all the high availability, all of the disaster recovery, and all the security features of the AWS platform. So today we're going to talk about 5 ways and 5 topics that can help you build better APIs. We're going to talk about API gateway design patterns. We're going to talk about how to secure your APIs, and then we're going to talk about how to deploy and publish your applications to production. And then we'll talk about how to handle errors, how to monitor your applications. And at the very end, we'll provide you some tips on how to build better APIs. So our first topic is API gateway design patterns. These are things that can help you improve your API deployments and your API designs. So AWS has a full spectrum of managed services, ranging from Lambda that can help you with compute, to S3 that can help you with storage, or various forms of databases. So DynamoDB can help you with NoSQL use cases. RDS or Amazon Aurora can help you with all of your relational database needs. But we also have API Gateway. API Gateway is designed to help you develop and operate your APIs. And then your APIs act as the glue for all of your applications. So all of these managed services have one thing in common. So when you interact with these applications and these managed services, you simply invoke an API. And these APIs respond with the business logic that you need. So you never have to manage any hardware. So you simply take all of these building blocks and combine them to create your modern day serverless application. So let's take a look at an example. In this example, we're building a serverless web application. And this web application is going to combine all of these managed services to create your web app. And we're going to host our application on S3, all of our static assets, HTML, JavaScript, and all of our binary content will be stored on S3 and delivered to your client. We'll be combining Lambda and DynamoDB to provide all the business logic and all the dynamic and real-time application logic to your users. Then we're going to have API Gateway that will serve as the glue between all of these. API Gateway will host application endpoints, and it will act as the glue, providing all of the necessary REST responses from your customers and also your application endpoints. So let's take a look at how API Gateway works. So on the left here, we have all the applications, mobile applications running on your phones, or web applications running in your laptops and your browsers, or even applications that are other applications. And these all connect to API Gateway using an HTTP-based request. An API Gateway receives that request and is going to determine what to do with that request. It's going to add CloudWatch monitoring, so you can easily check what's going on behind the scenes. It's going to determine if the application response is cached in memory, and then it's going to invoke a number of possible backends. So API Gateway can invoke any Lambda function. It can invoke any endpoint that lives on EC2, either public or within your VPC, and it can also invoke any AWS service behind the scenes. So there are three different types of API gateway endpoints, and we'll talk about all of those. So your next design choice is actually to choose the right API endpoint type. So there are three endpoint types. The first is an edge optimized endpoint type. Edge optimized endpoint types are designed to help you reduce latency from anywhere on the internet. So if you have customers and clients connecting to your endpoint from anywhere in the world, you want to choose this type. The second endpoint type is regional. And a regional endpoint type is designed to help you reduce latency when most of your calls originate from the same region that your API is deployed in. And the third and final endpoint type is a private endpoint. A private endpoint is designed to provide secure endpoints that only exist and are only routable from within your VPC. So you can use this endpoint to design really secure financial or HIPAA workloads. So let's deep dive a little bit into the edge optimized type. So the edge optimized type, when you deploy this type, API Gateway will deploy a CloudFront distribution that's managed by API Gateway. So this distribution will be used to accept the request from your customer at the closest POP location that's nearest to your customer. CloudFront will take that request and then route it to your API Gateway endpoint behind the scenes, and that will reduce your first hit latency that your customers experience. So by using this endpoint type, there are two things that you get. The first thing you get is reduced latency from your customers, and they won't experience latency because of a geographical difference. And second, you're going to get a managed CloudFront distribution. So you don't have to pay for this. AWS manages this for you on your behalf. The second endpoint type, as we talked about, is a regional endpoint type. The regional endpoint type, again, is meant for applications or endpoints where you have most of your calls originating from the same region. So this endpoint type is a little different from the one we just looked at. There is no CloudFront distribution that's deployed by Amazon. So requests flow directly from your customers to your endpoints that live in a specific region. Now, this endpoint also provides the most flexibility because you can design disaster recovery scenarios or load balance scenarios in a very customized way. So here's an example of how you would do that. So in this example, I have stood up my self-managed, customer-managed CloudFront distribution and in front of two separate API Gateway endpoints. One endpoint lives in US East 2 and the other endpoint lives in US West 2. And I'm using a DNS provider like Route 53 to route requests to the proper endpoint based on my chosen routing pattern. So that could be round robin, could be latency based, it could be anything that matters to your business. And this one is important, and this design pattern allows you to create really fine and really granular configurations for how you want requests to be routed to your endpoints. With this design pattern, it's worth noting that you can add all the custom features to CloudFront. So you can add WAF, which is the application firewall. You can add caching, and you can also add restrictions on which SSL certificates you want to allow customers to connect with. A third endpoint type is the private endpoint. So private endpoint is only exposed from within your VPC. So this endpoint type is still managed by API Gateway, but however, when you stand up this endpoint, requests are only routable and can only originate from within a single VPC, which is something that you own. So this is designed for applications that have very secure workloads. Typically, we see customers using this endpoint type when you have healthcare or financial data that can only live in your VPC and cannot be exposed publicly on the internet. So in summary, we've talked about three endpoint types. Your first design choice when you're building your API is to choose the correct endpoint type. And you can do that in the console very easily by simply clicking the endpoint type dropdown and then choosing regional, edge optimized, or private. Keep in mind that if your requirements do change, you can easily go back and change which endpoint type you want to use. So you're never locked into your first choice. So our second design pattern is to think about caching. So you should always consider whether or not your API responses can be cached. And what we mean by that is when you enable caching on API Gateway, you go into your stage environment, you go into your stage configurations, and then enable API caching like I've done here in this screenshot. Once you enable caching, you have the option of configuring a cache that is anywhere from half a gig to 237 gigabytes. And you can also configure and customize the maximum time to live for each cache entry. So when you have caching enabled, API Gateway will look for cache data when a request is made and respond directly from memory instead of invoking your backend. So remember, caching is typically meant for get methods only because get methods typically return information. So if you need to cache requests that are post or put, things that typically modify or update information, you can do that, but you need to be very careful and understand exactly what you're changing. So in order to use your caching, you need to define which request parameters will consist of the cache key. So in this screenshot, in this example, I've defined an item ID URL query string parameter, and I've enabled caching for this parameter. So every time my API Gateway endpoint sees the same item ID for a get method request, it will add the response into the cache and then use the cached response for every single downstream invocation that API Gateway receives up until the TTL expires. So what this does for me is that it reduces overall latency for my customers, but it also minimizes the number of requests that make it to my backend. And this is super important because as you scale, if you have data that doesn't change very often, there's really no need for you to invoke your backend. So that's the second design pattern. Always consider caching and try to cache things that don't change very frequently. A third design pattern is always allow and configure a way to control connections that make it into your API. So with API Gateway, it's really easy to do by using a feature called usage plans. So with usage plans, you can configure the number of requests per second or the transaction per second that make it to your API, and you can throttle based upon that. So you can apply quotas either at the API level, the entire API, or at the stage level, or even all the way down to the method level. And you do this by creating and generating API keys unique to each customer or each client who's going to use your API. Then you distribute this key to your customers, and then when they make invocations to your API, they'll have to provide this key in the X API key header. So what this allows you to do is allows you to throttle requests coming into your endpoint, and it also allows you to generate revenue as you're producing APIs that potentially could produce revenue for you. Now, it's really easy to look at how often and how much your customers and your clients are using your keys and your APIs. You can check your usage in CloudWatch. You can export your data usage per usage plan using the CLI or the SDK as well. So our next section is, now that we've learned some design patterns for building enterprise-grade APIs, we're going to talk about how to secure your APIs. So there are four main strategies that can help you protect your APIs. These are resource policies, IAM authorization, Lambda authorizers, and Cognito authorizers. Each of these have specific use cases and pros and cons for using them. So we're going to talk in depth about each one of these. And we'll start with resource policies. So a resource policy allows you to define API-wide IAM permissions that can do things like allow or deny specific ranges of IP addresses that can invoke your API, or you can allow cross-account invocations of your API, right? You can use a resource policy to allow other AWS accounts or users to invoke your API. And so here's an example. In this example, I'm providing allow permissions to invoke my API for a specific user called George. And that user lives in an account called account-ID for the purposes of this example. I'm allowing George to invoke an endpoint that lives in the /pets resource, but only the get method for that endpoint. So George has a very granular permission only be able to invoke the get method on the pets resource. You can create policies like this using a resource policy that is as granular as you need or as wide as you need. So you can allow specific users, you can allow entire accounts, you can allow service roles or IAM roles as well. So our second authorization mechanism is IAM authorization. When you enable IAM authorization, what this does is it requires all requests made to your API Gateway endpoint to be signed with the Amazon Signature version 4 signing process. And that signing process is essentially an HMAC signing process using SHA-256. And what it does is you need to use your API AWS keys, ID keys, and secret keys in order to generate that base 64 encoded string. And all of the authorization data will be included in the authorization header that you make in the request that you make to your API. So behind the scenes, Amazon API Gateway will take that signed request, parse the request, and determine whether or not that user who signed the request has the IAM permissions to invoke your API. Without the correct credentials, API Gateway will simply deny and reject that request. So this type of authorization is very granular and very linked to AWS IAM roles or users. So it does require a user to have those permissions before they can make a correct invocation. So a third authorization mechanism is Lambda authorization. A Lambda authorization is the most flexible authorization mechanism. So once a request is received by API Gateway will invoke a Lambda authorizer. So Lambda authorizer is simply a Lambda function where you can perform any custom authorization that you need. So you can take the identity information that you receive from your customer. This could be username and password, could be any combination of a secret, could be an OAuth token, could be almost anything that your application needs. API Gateway will forward that information to your Lambda function, and your Lambda function is responsible for performing authentication based on that. So you can use this to query a backend database, you can talk to DynamoDB, or you can check any custom identity provider. Very often we see customers integrating with an OAuth provider to perform this kind of authentication. So let's take a look at exactly how this works. So in this example, I've created a custom authorizer, and that authorizer has a name called my Lambda authorizer. It's configured to be a Lambda authorizer, and I'm accepting two identity sources. So my first identity source is a header called my custom header, and the second identity source is a query string called user ID. So API Gateway will look for these identity sources from the request. So on the left is an example where the user ID is George, and my custom header is some password. So API Gateway will parse this information from the incoming request and then inject that into my Lambda authorizer on the right. So my Lambda authorizer is responsible for taking that information and then performing authentication, performing my custom authentication, and then returning an allow or deny policy that allows my customer to invoke or not invoke my API. Our fourth and final authorization mechanism is using a Cognito authorizer. So Cognito is our application security managed service. So it allows a user to sign in, and it manages all of the user management for a user. So it allows you to sign in, sign up for an account, log out, and also perform all the password reset features of a IDP. So when you use a Cognito authorizer, a user would sign into Cognito. Cognito will return a JWT token, and a JWT token represents all of the claims, all of the details about a user. So the user would take that JWT token, include it in the authorization header, and then pass it to the API Gateway and try to perform authentication. API Gateway behind the scenes will automatically interact with Cognito to perform authorization on that user. So by using this method, you get to offload your identity information to Cognito, and the Cognito perform the authentication, and API Gateway will handle all of the details behind the scenes. So we looked at 4 different authorization mechanisms, and just keep in mind that you can actually combine a resource policy with any of the other 3 mechanisms to create really granular and very secure applications. So our next topic is how to publish applications to production when you're ready to move into production. So essentially CI/CD for your serverless applications. So let's take a look at some ways we can do that. So the serverless application model, or SAM, is a simplified way of defining serverless applications. And it's essentially a CloudFormation extension that's optimized for serverless. And SAM adds 3 serverless resources. So those are serverless functions, serverless APIs, and serverless simple tables. So these map to a Lambda function, an API gateway endpoint, and a DynamoDB table. Today, we're going to be talking about the AWS Serverless API to help you understand how API Gateway can be managed with SAM. So here's an example where I'm using CloudFormation to produce and document a fully functional serverless application. And my serverless application is a DynamoDB table, it has a Lambda function, and also has a REST endpoint hooked up. And it also has all the other details that describe how all of these pieces fit together, including IAM roles and other policies that manage all of my permissions. So as you can see, this is a very verbose description of my environment. It's multiple pages long, and it potentially has typos in it. So if I want to use SAM, I can produce and document the same application in just about 20 lines of code. So with SAM, in this example, I'm defining a serverless function, which is my Lambda function, and it's named getHTML function. And this function has a runtime. I'm choosing to implement this Lambda function using Node.js 6.10, and it has a single policy on it. That policy allows me to perform DynamoDB read-only permissions. So this application cannot perform any write permissions against my DynamoDB table. Now moving down a little bit, we see that there's an event. So this event is called getHTML, and that event has an event source of an API, and that API is my API gateway endpoint. So my API gateway endpoint is allowed to invoke my Lambda function. And also at the very bottom, have a DynamoDB table configured. The resource type is simple table, and the DynamoDB table is called list table. I can easily tell this is a SAM template because on the second line, there's a transform directive, and it's telling it to transform from an AWS serverless SAM template to a CloudFormation template as I make my deployments. So in order to use SAM, if I wanted to define more complex APIs, so on the very left, I'm defining a more complex API. My API is called My API. And you can use Swagger to fully document and define every single piece of your API. And Swagger is a very industry standard type way of documenting and designing your APIs. So you can document and design your APIs in an external file called swagger.yaml. You can call that file anything you want, but in this example, I'm showing it configured as swagger.yaml. And then you can inject this API into my Lambda function event on the right. So on the right side, I have a Lambda function, and at the bottom is an event source called my API, and the property is a REST API, and it's referencing my API that I've created on the left using a fully documented Swagger YAML template. So for more complex APIs, we definitely recommend you using Swagger instead of using CloudFormation. So when you install SAM, it's actually a CLI tool. So when you install SAM, you have access to all of these commands on the bottom. So you can do SAM init, SAM package, SAM local, SAM validate, and SAM deploy. So all of these allow you to do different things. So SAM package allows you to package an application and prepare it for deployment. SAM local allows you to run an application, serverless application locally on your machine. SAM validate will validate that SAM template that we saw earlier and make sure there's no syntactical errors. And then SAM deploy will deploy your application using CloudFormation into your AWS environment. So let's take a look at how we can use SAM to deploy your application. So 2 steps you need to take. The first step is SAM package. So the SAM package command takes 3 parameters. So the first parameter is a template file. So the template file we saw earlier defines my serverless application. So my API is defined in there. And then we have a S3 bucket parameter. So this bucket is going to hold all of the outputs of the SAM package command. And then SAM package will generate an output template file called deployme.yaml. And then you can name this file whatever makes sense in your CI/CD pipeline. But for this example, I'm using deployme.yaml. Your next step is to use SAM deploy. And the SAM deploy command as an input takes the output of the previous command, so as a template file. So this deployme.yaml will be the first parameter. And then you have to pick a stack name. Because this is CloudFormation in the back end, I'm choosing a stack name that's unique for my API. And then the SAM deploy command will invoke CloudFormation and then deploy my entire package. If you are creating IAM roles or permissions, you do need to add an additional flag called capabilities, and capabilities_IAM provides CloudFormation with the permission to create IAM resources. So this is a two-step process: SAM package, SAM deploy, and then this automatically roll out your environments. So the next thing you should consider is always consider deploying your APIs with canary deployments. So a canary deployment allows you to route a certain percentage of your traffic from one canary to another. So in this example, I have a canary deployed on my pet store API. And my pet store API has a live production environment called prod. And my prod environment has a cart on it. So /store/products and cart. Cart currently only accepts a post method. So it doesn't accept a get method. But what I want to do is introduce a get method. However, I want to make sure that this get method works without any kind of problems before rolling it out to my larger user base. So I create a canary deployment and I send 90% of my traffic to my current good known working version. And I only send 10% of my traffic to my canary. And during this 10%, I can test all of the requests and only impact a small percentage of my users. And what I would want to do is add a get method to this request. When I add this get method, I can test this request against just a few users. And then when I'm reasonably sure that this new get method doesn't have any problems with it, I can promote my canary. And when I promote my canary, I'll merge my canary with my current production deployed environment, and all of my traffic will route 100% to my new stage. So on the right side, I have a production stage that has a canary promoted, and my cart now has both get and post on it. So our next topic is how to handle errors and how to monitor your applications, because any production application, any enterprise-grade production application requires you to manage and be able to understand your application both from metrics and from a logging perspective. So API Gateway offers 7 different metrics. And metrics are basically a way to view your application at a very high level, to understand how your application is performing and how your application has any errors or if you need to respond in any way. So API Gateway has 7 metrics out of the box, and they're all free at the stage level. So you can look at things like how often your APIs are being called, the number of invocations to your API, the latency of your API responses, if there are any errors, whether it's 400 errors or 500 errors, and also whether or not your cache is being hit or your cache is being missed. So if you want to look at more detailed metrics, you'll need to enable detailed metrics. When you enable detailed metrics, you get to see all the metrics at the method level. So all of this gets and the posts and the deletes all need to be enabled using detailed metrics so you can view all of those metrics as you move into production. So you go into your stage settings and you simply enable detailed metrics. So the 2 most important metrics are latency and integration latency. So the latency metric provides you details about how long it takes for a full round-trip response from the second your customer invokes your API to when our API responds with the results. So this is a full round-trip duration of an API gateway invocation. Integration latency is just how long it takes for API gateway to make the invocation to your backend and receive the response. So if you take the difference between these two, you can determine what the overhead is for API gateway. And these 2 are really important because it allows you to fine-tune your applications and see what impacts your applications and where the bottlenecks are. So this is an example of an application dashboard that I've created. And this application dashboard on one screen shows me on the top left the overall latency and integration latency for my application. On the bottom left, I have another dashboard that shows me my cache metrics. So it's showing me how often my cache is being hit, how often my cache is being missed, and the total number of requests made to my endpoint. So on the right side, I can see that I started with 17 total API calls, and it dropped down a little further towards the 8 number on the right. And the bottom right, perhaps, is the most important piece, is number of errors that are occurring on your API. So these are 400 errors or 500 errors. I can see that I have no 500 errors, but I have a few 400 errors. And if these errors are continuing to increase, it's a very good indication that your application is experiencing a lot of errors, and you need to perhaps respond to that. So if API Gateway metrics provide a high-level overview of how your application is performing, API Gateway CloudWatch logs give you a very detailed view at how your application is actually running. So API Gateway has two types of CloudWatch logs built in. The first type is execution logging. So execution logging gives you logging of how a request is occurring from a round trip perspective. So you can see all the details from when the request was made, all the request parameters, and everything that happened between the request and what happened when API Gateway returned the results back to your calling client. API Gateway access logging provides all that details about who's invoking your API. So everything including IP address, HTTP method used, the user, the protocol, the agent that's invoking your API can all be seen using API Gateway access logging. And these logs are fully customizable using JSON formatting, XML, and you can publish that and push that to a third-party resource to help you analyze these logs if you need to. So here's an example of customizing my access logging. So I went into my stage settings and I'm configuring my API gateway to write my access logs in a JSON format. So on the right, you can see that I'm logging request ID, IP address, the request time, and all sorts of other information about every request being made. So I can easily see all of this information as it gets published to my CloudWatch logs group. And then I can route this request to another service if I need to perform auditing or if I need to perform any kind of searching on my logs. So it's always best practice to enable custom access logging as you're deploying your APIs out to production. So our final section is going to be just a few tips that can help you build better APIs, things that are best practices that can help you enhance both your production experience for your customers and also your development experience for your developers. So tip number one, never hard code anything. And what we mean by that is always take advantage and use stage variables. So a stage variable is defined in your stage settings or in your console. And you can reference them using the $stage variables notation. And then using the dot notation, you can reference any single variable. So you can use this design pattern to inject stage-dependent things. So you may have multiple stages deployed for multiple environments, and they need to invoke different endpoints and different backends, but you don't want to hard code that. So for example, if you have different endpoints with different URLs or different Lambda functions based on your environment, then you can use stage variables to inject those variables. So let's take a look at how that works. So I've defined two stages. On the top, I have a demo stage, and on the bottom, I have a production stage. Both of these stages need to invoke a Lambda function and also need to invoke an endpoint, an HTTP endpoint. But they need to be different resources based on whether I'm in the demo stage or the production stage. So I've defined a Lambda function variable, Lambda fn, and in my demo stage, I'm pointing at my Lambda function using the demo alias. And then I have a URL, which is www.myendpoint.com/demo. So my demo stage always points at my demo resources using stage variables. On the bottom, I'm doing the same thing. So I have two stage variables set up, except this time my Lambda function points to Lambda function production. So this is a Lambda function with a production alias. And then my URL points to the same endpoint, but it's pointing to /prod instead of /demo. So I've defined two stage variables, and then let's take a look at how we can actually use them. So in order to use my stage variables, on the left, I'm integrating with a Lambda function. Now this Lambda function, my Lambda function, instead of using a hard-coded Lambda ARN, I'm going to use the stage variables $ notation. So $stage variables .lambda fn. Now this will retrieve dynamically at runtime the proper value for that variable that I've defined in my stage settings from before. Same thing on the right side. So in this integration, I'm invoking an HTTP endpoint. And this HTTP endpoint is going to use a stage variable and is going to use my other stage variable .url. So at runtime, API gateway will pull the value for URL and then invoke that HTTP endpoint based on what I've defined in my stage settings. You can use this design pattern, and we definitely recommend using this across the board so you never have to hard code anything, and it makes it easy for your developers to deploy and push things into production, especially in a CI/CD pipeline that's automated. Tip number 2 is to always control access to your APIs and always understand that there's 2 different permission sets for API Gateway. So the first permission set is execute-API permissions. And this is the data plane API permissions. So this defines who can invoke your API. So in this example, I'm allowing permissions to invoke an API and a specific API, and that resource is /my demo resource, but I'm only allowing invoke permissions on the post method. And I would take this IAM policy and attach it to any IAM principal or role so that that principal or role has permissions to invoke this specific API. Now the second permission set is API Gateway permissions, API Gateway star. These are control plane permissions. Control plane permissions dictate who can control and manage your API. So API Gateway has multiple different control plane permissions. The most common ones are API Gateway get, post, delete, and put. So these allow you to manage and describe, update, and delete your API Gateway endpoints. So on the right side, I'm providing on the top first statement, I'm providing an allow permission to allow API Gateway get. So this allows whoever has this permission to describe an API get, to describe an API Gateway endpoint for all REST APIs. So I'm using wildcard permissions there. On the bottom statement, I'm allowing all API Gateway permissions, so API Gateway star, for a specific endpoint. So that endpoint lives in US East 1, and it has a specific endpoint as defined with the string, the unique string A123456789. 9. So you can make these as granular as you want or as wide as you want. But the most important thing to understand is the differences between an execute API permission, which is invocation permissions, versus an API gateway permission, which is the ability to manage your APIs. So typically you want to provide your developers with permission to manage your APIs, and you want to provide your customers permission to invoke your APIs. So our third and final tip is a few best practices on how to manage your environments, your stages, versions, and your canaries. So in Lambda, a best practice is always to enable versioning. And when you enable a version Lambda function, every time you publish that function, we create a new immutable snapshot of that function. But instead of using that function version ARN, the best practice is create an alias that points at your version. And then in API Gateway, you would take that alias and use that instead of using the version. Because what this allows you to do is when you have new publishes of your API Gateway or new deployments, you simply have to change what that alias points to. You never have to go in and change the hard-coded version that the API Gateway points to. Another tip is that when in API Gateway, you should use stages for environments and not versions. Right? So instead of publishing multiple versions using a stage, use stages for different environments like production and QA and test. And this makes it easier for you to manage your environments instead of using versions that link to stages. Our last tip here is, if possible, you should create different stacks for different environments. So different stacks for development, testing, staging, production, or whatever matches your CI/CD pipeline. The best case is if you can create different accounts for different environments. And this will allow you to do is create the exact same deployments that go across different accounts. And this will make your deployment configurations and all of your application deployment targets much easier. So this wraps up our content for today's webinar. I want to thank you all for joining. I hope you learned a lot about API Gateway and how to deploy to an enterprise grade API Gateway endpoint. I want to thank my moderators for helping out. And I do want to provide a few links so you can get more resources about AWS Serverless and API Gateway on the bottom bottom right here. If you have any questions, or we would love to hear from you, and please let us know what you're doing with the API Gateway. Thank you.